I am Professor Goura-Bandhu. Put down those boring spreadsheets. I am Bandhu, researcher. Professor, please slow down. I've been auditing this sweet pea data from 1877 and my head is spinning. This scatterplot shows parent versus offspring seed sizes from Galton's experiment. We start with giant mother peas, but they consistently produce smaller daughter peas. The heredity engine appears to have a leak. This shrinking is the signature of a beautiful mathematical law, the Great Regression. Galton chose the self-fertilizing sweet peas specifically for this experiment. Because it self-fertilizes, he tracked heredity cleanly, without a second parent confusing the data. The garden maintains statistical balance through the very measurements that appear to be failing. Think of the mean as home base. When you throw a yo-yo toward the floor, representing an extreme data point, a rubber band of math pulls it back. Over generations, nature pulls extreme offspring back toward the average. Nature actively damps the outliers. Without this regression, the garden would spiral into a chaotic jungle of infinite giants. I understand the damping effect now. This lesson is inspired from the Goura-Bandhu discourse on the philosophical nature of the mathematical gardener. We map this using the deviation equation. Y equals R times SY over SX times X. Here, R is the correlation coefficient, our baseline rule of association. This diagram shows variability affecting predictions. Look at plot A. Parent and offspring variability are equal. The slope matches the correlation. In plot B, offspring vary less. The line becomes shallower, squashing predictions toward the mean. The ratio of standard deviations acts as a crucial correction factor on the correlation, preventing our predictions from flying off into infinity. Math challenge. If correlation R is 0.64 and the offspring variability SY is exactly half of the parent variability SX, what is the regression slope B? Go. Multiply 0.64 by 0.5. The answer is a squashed slope of 0.32. Laura, we build upon the deviation slope to predict raw scores using the full linear equation, y equals bx plus a. This line shifts on the coordinate plane to intersect the y-axis at point A. Goura, the immediate parent isn't the only influence. Grandparents also toss toys over the fence, as shown in Galton's unit square. Galton's law of diminishing influence shows that grandparents mathematically contribute 1/4 of the total influence on an offspring's traits. Karl Pearson's product moment proof provides the definitive mathematical path of least resistance by minimizing squared errors. A moment of wonder. Even the tallest peas miss their home in the middle, Bandhu. Mathematical regression is nature's balancing act, ensuring a sustainable population. Goura's cheat sheet. 1. Regression balances nature. 2. R is the association. 3. The ratio of standard deviations is the correction factor. And 4. Slope B is the product of the two. Stay curious.